Before we proceed to the sample problem, another sample problem, I would like to discuss yung laman ng pump characteristic curve natin, no? So, we have this one, free delivery, okay? So, it is defined as the maximum flow rate through a pump occurs when its net head is zero. So, when we say net head is zero, it means we don't have the restriction. So, there is no pressure loss. So, it means it is not connected directly to the piping. So, once kasi pag connected ka sa piping, there will be a head loss. So, when we say H is zero, so there is no restriction, no gate valve, no let's say concentric reducer or piping or whatsoever. So it is achieved where there is no flow restriction. Okay, so for example, this one. So if we have this suction, okay, just simply as putting the suction here and discharging the pump. Okay, so that is a free delivery. Okay, and the pump inlet, in other words, there will be is no load. Okay, that defines, and the efficiency is zero. Now, for shot of head, so you will notice here, ito yung shot of head basing on our pump characteristic curve. So, shot of head is defined as it is the net head that occurs when the volume flow rate is zero. Okay, so you will notice here, shot of head, we have here the specific head, and you have the corresponding, the volume flow rate is zero. So, starting here. And it is achieved when the outlet port to the pump is blocked. So when we say it is blocked, you will be providing a blind plunge dito. So to make sure it is being blocked. Okay? Or let's say if the piping are closed. So when we say that the piping is closed, so for example, it is connected to a piping, no? Then you have your gate valve dito. So you have your discharge here. For example, I've tried to remove the blind plunge dito. So it means we have purely connected the pipe to the pipeline, the pump to the pipeline. So we have your gate valve here. So this is closed. Okay. So it means there is no, we call this fluid going out to the system. So it is completely closed. And you will notice under this condition, the head is large, but the Q is zero. Now, the pump efficiency is also in zero. Now, we have here the best efficiency point. So, the pump efficiency reaches its maximum value somewhere between shut-off condition. So, we have your shut-off condition and the free delivery condition, this one. This is the operating point of the maximum efficiency. So, this is your best efficiency point line. So this is a location at which yung pump mo will perform at the best. When we say the best, so it has a corresponding a good horsepower characteristic. Also yung kinukonsume ng electric mo in terms of best efficiency point. So usually we try to design our pump, we try to select our pump on this type of best efficiency point. Kasi kung nandito ka sa best efficiency point, at this point you can save money, and also when you save money, you can save the electric power consumption of electric motor. Kaya that's why we have this best efficiency point. So that's why when you're in practice, in actual, so dapat you're going to select yung pump which is near to the best efficiency point. So at this point, you can save electrical power. And when you say electrical power, it has a corresponding to electric bills, and also, and when we say electric bills, so that is payment of electricity, so that is money. Okay, you can save money when you are in this point of selection. So don't forget that when you are in practice, so don't forget when you do selecting the pump, so please refer for always in the best efficiency point. And we have here the problem. Now, the performance data of an centrifugal water pump are shown in table for water at 20 degrees Celsius. Now for A, we have to find for each row of data, calculate the pump efficiency in terms of percent, and B, estimate the volume flow rate, liters per minute, and the net head at the best efficiency of the pump. Now, if we can still remember, no, the pump efficiency, so So we have here the pump efficiency. So that will be equal to the water horsepower. So that is divided by the brake horsepower, or let's say the electric horsepower that is being produced by an electric motor. Always remember that the horsepower that is being produced to the pump is what we call yung water horsepower. So ito yung power na produce ng pump. Okay? Then we have yung brake horsepower. So that is yung pinuproduce ng electric motor. Okay? So if we can still remember that our water horsepower, so that is equal to your volume flow rate. So that will be multiplied by the uh, specific weight. Then we have your total dynamic head. Then this is divided by your brake horsepower, which is given already in the problem, no? Now for our volume flow rate, so for example here, let's start with 0.0. Okay, so you have a volume flow rate of 0.0. So usually kung 0 naman, automatic multiply mo, that will be 0. So let's try other values dito. So let's try to use yung 6, no? So let's try to use 6 liters. Okay, I'm gonna use the 6 liters. So we have here 6 liters, 6.0. So this is liters. So let's try to convert this one in cubic meter. So usually 6, so 1 cubic, you have 1 cubic meter. So this is divided by 1,000 liters. Okay. Then we shall multiply the specific weight of water. So that is 9.81. So we can kilonewton. So let's try to expound that one. So that will be 9,800. Okay, 9.82, 9,810. Okay, so that will be newton. So this is weight. So that will be kilonewton or newton per cubic meter. Then we shall multiply this by the total dynamic head, which is in terms of meter, which is given to the problem. So we'll be using 46.2. Okay. So you simply 46.2 meter. Okay. Then we shall divide it by our brake horsepower, which is equivalent to 100. Let's try to use 100. We'll be using 142. We have 142. So this is in terms of unit of watts. Okay, so on watts, so if you're going to expand in unit, that will be newton meter per second. If you're going to expand yon, so I'm gonna erase this one so para hindi kayo ma-confuse. Okay, so that will be newton meter per second. So that is the unit of watts, expanding unit of watts. Now, so let's cancel ang common units natin dito. So we'll be canceling yung liters. So we have now in cubic. So cubic will be cancelled out. Then naiwan na lang natin dito, which is newton. So because usually efficiency is in percent in terms. So there will be no unit. So dapat magka-cancel out siya. So your unit natin ng newton will be cancelled out. We have your meter. So we have, oh, we forgot, this is liters per minute, no? So we have here, we forgot to add yung minute per minute dito sa ilalim. We're going to add that one. So we'll try to cancel yung minute. So 1 minute, okay, so para mag-cancel out siya na other doon sa ilalim. So 1 minute, that is equivalent to 60 seconds. 60 sec. So eventually magka-cancel out na rin yan. So we have your minute and minute here, and you have your second and seconds here. So finally, we have, if you're going to use your calculator, so we have the value of your pump efficiency, which is equal to, so we have the value of 32. So that is, we have 31. If you're going to express it in percent, that will be 39.9%. So that will be the efficiency at this point when you have the corresponding 6 liters and we have 46.2 meters of head, and with a corresponding brake horsepower of 142, that will be equal, pump efficiency shall be 31.9%. Okay, now if we're going to continue to solve the problem, so ito rin naman yan yung equation that we have used. So substituting it directly bawat isa yung mga values natin from the table. So we may able to get yung pump efficiency at different flow rate, at different head, and in also at different brake horsepower. Now, from here, so if you're going to select what will be the best efficiency of the pump, so ito yung 64.8. So it will be the best efficiency point with the corresponding 18.0 liters per minute of volume flow rate, with the corresponding 36.2 meters of head, and a brake horsepower of equivalent to 164. That will be the electric consumption of the electric motor.